Hello everyone. So last night, Codeforces hosted a rated contest by GRAKN Lab, and I am going to solve two of the questions from that contest now. And the first question is coloring circles. In this question, we are given a number and three arrays of size and such that ith element of each each of the following array are distinct. Like, okay, so you understood that ith element of each array are distinct. Okay, so our task in this question was to find a sequence p1 comma p2 up to pn such that p's ith element belongs to uh, a's ith element. Consider this I to be one indexing c's ith element, and second condition was that no two numbers of pi, that is no two numbers of the sequence adjacent numbers of pi should be equal. That is, if we have p1 p2 p3, then p2 shouldn't be equal to p3 and p2 shouldn't be equal to p1. Okay, and there was one more condition, that is p1 and pn are considered to be adjacent, so p1 cannot be equal to pn. Okay, so this question is pretty simple because all you had to do was like the first digit, there were multiple answers possible for this question. All you had to do was let p1 be anything of the p1 can be anything, that is either a0, p0 or c0. So I kept p1 as is equal to a0, and what I did was I iterated my loop from 1 to n minus 1. My variable I looped from 1 to n minus 1, and all I did was check if a's ith element is equal to the previous element or not. If it is equal, I will check for b's element, else I will check with c's element. So the thing is, let's call the previous element which appeared in the sequence to be a variable called prev. Okay, so uh, if ai is so all you have to do was uh, okay, so we have three options to choose, and out of these three options, none of them should be equal to the previous element. So it was a pretty simple question. So if suppose my previous element is something called as prev, so if ai is equal to previous element, then we cannot print ai. So we'll check pi. If pi is not equal to previous element, then we'll print pi, or if it is equal to previous element, then we'll print ci. So this was a pretty easy question. The only edge case in this question was the last element, that is when I equals to n, one indexing I equals to n, then we have to check that pn is unequal to p of n minus 1, as well as p of n is unequal to p of first element. This was the only major case you need to take care of, else the question was pretty simple. So I will show you what I wrote in my code. So I got the three arrays a b c, and previous I stored the first element of the a array in a variable previous, and I printed a naught in the beginning. Okay, after that I ran a loop for loop from 1 to n is excluded. So I ran a for loop from 1 to n, and what I did was, if my variable of the loop is unequal to, sorry, if it is equal to last element, then I have to check that the either of ai or bi or ci, whichever I am going to choose, I have to make sure that it is unequal to p of n minus 1, and it is unequal to p is like the first element. So all I have to do was, if this is unequal to n minus 1, then I will check if ai if AI is okay, wait, if AI is unequal to previous and AI is unequal to a naught, if this is true, I will print AI, else I will check the same condition for BI, or else I will print C directly. Okay, so this was the only thing, this was the only major case in the question. Otherwise the question is pretty simple. You can see my, I will put a link to the problem in the description, and probably I will share my code as well. Okay, so this was a pretty simple question. Now I will move to the second. Hello. So about the second question. In this question we were given two integers n and k and an array of size n, such that this array was non non-negative and non-decreasing. Okay, so this array was non-negative and non-decreasing, that, and we were given a integer k. So our task was to find out sorry m uh, so b1 b2 up to bm are m arrays such that a's ith element is equal to bi's ith element plus b2's ith element up to bm's ith element. We have to find such an array of bi, uh, such an array, such an array set of arrays rather, and such that it satisfies this condition. Plus we have to minimize m, that is minimize the number of array, given the condition that each array belonging, each array bj j belonging to j belongs 1 to from 1 to m, such that the bj array is also non-negative and non-decreasing. Okay, so how to approach such a question? And also one more condition was the bj contains at most k distinct elements. Okay, so how are we going to approach this question? uh, there is one thing we need to calculate for each question, that is number of distinct elements in AI. That is the array which we are given. In that array we have to find the number of distinct element. Let me call that by count variable. Okay, let me tell that by count variable. So what is the advantage of finding this distinct element? Suppose we have array AI. Suppose I will make this array 4 5 6, okay, size 7 maybe. And suppose the number of distinct element I am, and the value of k is equal to 3. So I can create the, okay, let me call this set of b1 b2 up to bm, the set of these arrays, uh, let me call it summing arrays. Let me call this set as summing array so I don't confuse you with different terms. Okay, so this is summing array. So how are we going to make the summing array? So I know that each I know that each of the summing array will have maximum 3 distinct elements. So if I write the first summing array as 1 2 and 3, and I can have at most I can have at max 3 distinct elements, right? So I will have to write a rest of the number as 3 only. Okay, so a rest of the elements are 3. So when I write this b1, what I'm at b1 like this, what I'm actually doing is I'm taking care of this one, this summation of 1, like the I am taking care of this 1, I am taking care of this 2, and I am taking care of this 3. So this implies that after that in b2 my first 3 elements will are fixed and they will be 0. Now after that I have to take care of remaining elements. So basically you got a strategy what we are going to do. So you can tell me what this number will be. This will be 1, this will be 2, because 3 plus 1 is 4, 3 plus 2 is 5, and since we have exhausted our capacity of distinct element, rest of the numbers will be 2 2 as well. And now we write a element b3 such that so we have taken care of this 4 in b2 and 5 in b2, so all these terms will be 0, and the last two digit will be 1 and 2, because 1 plus 2 plus 3 is 6, and 2 plus 2 plus 3 is equal to 7. So in this way we get answer is equal to 3. So you might have understood what technique I used while writing this summation array, that I will start fixing every single term till the end. Now what is the advantage of finding this count, that is the number of distinct element? Suppose my array was 1 2 2 uh, 3 4 5 6. So in that case b1 would have been 1 2 2 and 3. So the number of distinct elements just implies that uh, how many terms I need to, how many different terms I need to fix. So in this array we had seven distinct terms, so I had to fix the sums for 7 distinct terms. Here I have 6 distinct terms, so I just have to fix 6 terms using the summation array. So now all you have to do is we can say that when I find out the first array, uh, so initially when I have nothing, when I haven't made the set of like the summing array, I have to fix count number of digits. Okay, after that when I write my b1 array, I fix count minus k, because I fixed the first k elements 1 2 3, so I fix the first k elements. So after b1 I am left to fix count minus k element. Now this is an important observation what I am going to do now. When I write b2 array, I just fix k minus 1 array, because because if I have k choices, one of my choice of this distinct digit goes in the utilization of 0. Okay, so one of my distinct digit choice goes to the utilization of 0, so I cannot so basically I cannot like the one of my choice of k goes to fixing the 0, like to write the 0, so I'm left with k minus 1 distinct terms, which I will use to fix two other unfixed terms. Okay, so when I write b2, I will still be left to fix count minus k minus 1 terms, and similarly for b3 it will be count minus k minus 1 minus k minus 1, that will be 2 times k minus 1. Okay, so now there is, but the thing is you will fix it that way. But what about but can you think of a case where the arrays the array A cannot be made using this summing arrays, and such a test case was given in the in a sample test case, that is when n was given to be 4, k was given to be 1, and the summing array was like the a, that is the given array was 0 comma 0 comma 0 comma 1. So in the first, the bith element, according to my strategy, we will write as 0 0 0 1, sorry 0 0 0 0, because we can use only one element in bn. And if I write b2, now you know that for if I have k, the first array will fix k terms, and the next array can only fix k minus 1 term. But if I have k is equal to 1, so my arrays which come after b1, that is b2 b3 b4, can fix 0 terms. In short, they cannot fix they cannot do anything. So basically in this case the target like the given array cannot be written as a sum of these, like the summing arrays. So in this case we have to print -1, but so this is one of the case where we are getting -1. So you understood my strategy. You understood my strategy, what I'm using in this question. Now only thing is to write the pseudocode for this question. Okay, so in this question we'll take the input n comma k, we'll take the array a. So first thing you have to check is if k equals to 1, and if k equals to 1, then we will check okay, wait, before everything happens we have to find the, sorry for my mistake, we will get an array, sorry, we will get two distinct numbers n and k, we will get the array. After that we will find the variable count. What is count? The number of distinct arrays, sorry, number of distinct digit in array, in digit in, sorry, distinct numbers in array a. Okay, we will find the value of count, and after that if k equals to 1 and if count is also equal to 1. Okay, if k equals to 1 and count equals to 1, that is the array consists of single digit, whatever that digit be, and if k equals to 1 we can fix at most one digit. So we can write if count equals to 1, if k equals to 1 and count equal to 1, we can directly print that we will need 1, that the minimum value of required arrays will be 1, else we'll print -1, because we won't be able to fix, we won't be able to find the set of the summing arrays. Okay, else what we'll do, suppose I declare a variable answer, uh, I declare a variable answer and term it to be 0. Okay, and now uh, if my k, that is number of permitted elements, is greater than or equal to count, that is I that the b, like the b1 array or can have k many distinct elements, and if it is greater than count, then you know that I can fix the array in just one step. Else what I am gonna do is, else uh, you know that b1 fixes k elements, and after that all the array fixes k minus 1 element. So I will write a code, and I think it should be clear enough what is going to happen. I will decrease k, sorry, I will decrease count, I will decrease count by k. So count minus equal to k means count is equal to count minus k. So count decreases by k, and I will increase the answer by 1, because this was a first step in which we took care of first k element. And after that, uh, if count is divisible by k minus 1, answer should be increased by count double slash k minus 1, count divided by k minus 1, and print answer, else answer plus is equal to count double slash k minus 1 plus 1, and this extra one is for a this we need to add this extra one, because if count is not divisible by k minus 1, then there will be so count double slash suppose our, okay, wait, I will explain this test case later on. So answer plus is equal to count double slash k minus 1 plus 1, and print k minus and print sorry, print answer. Okay, now I explain how this plus 1 came. Do I have such a test case over here? Okay, I will do it on some other page. Suppose our given array a is equal to 1, 2, 6, and our k is equal to 3. So according to our strategy, the b first array should be 1, 2, 3, 3, 3, 3. So this will fix at this step. So here we had to fix 6 elements because there are 6 distinct elements. Here after this b1 step is complete, we will have to fix 3 elements. After that, after this step we are left with one distinct element. But okay, so we are requiring uh, so after this we still need to fix one element from the array. So we'll write b3 and that will be 0 0 0 0 1. Okay, so after that our array is fixed. So here we require 3. So if I see what happens in my code when I write this, so 6 minus 3 equals to 3, and answer becomes 1. Like you can see over here, see the k is less than count. So my code will go in this else loop. Count was 6 and count will decrease by k, so 6 minus 3 equals to 3, so count will become 3 and answer will become 1. After that, if count mod k minus 1, if count, that is 3 is not divisible by 2, 3 is not divisible by 2, so it will go in this loop. So answer will increase by 3 double slash 2. So 3 double slash 2 is 1 because it will return an integer value plus 1. So this one comes from 3 double slash 1, 3 double slash 2, and this additional array is due to that plus 1 term I introduced in the end. So in this way we can this is the solution of the question.